Dear students, today we will talk about the yet another type of terrestrial telescope. Well, we have earlier talked that how we can make the final image erect with respect to the object. It was done by introducing a inverting lens, convex lens in between the two objective and eyepiece of a normal astronomical telescope. But in that case we found that it also increases the length of the telescope. Here Galilean brought some new idea. He introduced this concept that instead of using eyepiece as a convex lens, he used a concave lens, and the objective was big, but I haven't drawn it as big. The concepts remain same. Now the ray coming from the star or distant objects, they will converge somewhere at the focus of the objective. We assume that the object is far distant, very far. Then in that case the concave lens is placed such that focus of the concave lens is coincided with the focus of the convex lens. And once this is done, then onward the position of concave lens is shifted such that the virtual image, which is erect with respect to the object, is formed mostly in between the two lenses. So that way the effective length of the telescope is rather reduced by some amount, and also the loss of brightness due to introduction of one extra lens is also avoided. So this is how it works. Now we talk about reflecting type of telescope. You see, reflecting type of telescope means here we have used refracting type of telescopes where light is suffering refraction while passing through the lenses. Here we are using reflecting type of telescope. This is mainly of two types, Newtonian telescope and Cassegrain telescope. Newton first of all introduced this idea, and he used concave mirror to collect the light rays coming from distant stars, and then had there been nothing in between the rays converging, the ray would have converged at the focus of that mirror. But he introduced a plane mirror in the path of those light such that instead of converging at point F, they converge at some point, say we are mentioning it by FO. Now he used another lens which is known as Ramsden's lens. It is especially designed to remove the aberration. So it is placed, this eyepiece is placed such that the focus of the eyepiece coincides with the point where these rays are made to meet due to reflection from the mirror. So that means then the rays emerges out of the eyepiece, becomes parallel, and so the image is formed at infinity. Here you see, in this type of telescope, you see we have magnification given by FO by FE. You can understand how we have written this magnification is equal to FO by FE, because if you compare with the previous cases, we were having two lenses, and then rays were coming from distant stars and they were converging to make some inverted image somewhere, and that image was acting as object for the eyepiece. And then we found the angle that the object makes alpha with the eye, and angle that image makes beta with the eye. So we found that in the same fashion you can understand here two parts mirror, and these two mirrors are doing the same thing. So we can have the magnification given by FO by FE. The brightness ratio we define for this type of reflecting type of telescope. We also define a term brightness ratio. You see the light coming from distant stars do not have as much brightness of light, and then since same amount of light is now allowed to converge or collect in a smaller area, and therefore the ratio of the area of the collecting mirror and the eyepiece, this ratio is known as the brightness ratio. Means the same star would become more visible as the concentration, the intensity of light is increased, and that is measured in terms of brightness ratio. Now in Cassegrain telescope, here you see one thing what was observed, that the mirror which is placed in the path of those light which were supposed to meet at point F, this mirror itself acts as an obstruction for the light ray reaching the mirror and getting collected. Means this much amount of light ray was eliminated which would have incident on the mirror and collected. So this obstruction was reduced by a great effect, because you see here Cassegrain used parabolic mirror, and then he placed a cut in the center of the mirror. So when the light rays were about to converge somewhere, there a convex mirror was placed, which was diverting the light rays in this direction and forced to pass through the eyepiece, where they again become parallel. And so here the obstruction length is of course reduced, because convex mirror needs less area to do the same job what the plane mirror was doing. And also here you see the object lies on our right and you are seeing on towards in this direction, so it becomes very awkward, because you can imagine someone is lying in this direction and you are looking in at a 90-degree direction, 90 degree to that direction. So here you see you don't have this awkward feeling, because object lies in the right of me and a person is seeing towards the right, so it becomes very comfortable for someone to view something in the same direction in which it actually lies. Here also the spherical aberration is very much reduced, because he used parabolic mirror. In case of concave mirror, this aberration is appreciable, but in case of parabolic mirror, this aberration is not there. So these are the benefits. Of course, the brightness and resolution means clarity of image is much greater in case of the reflecting type telescopes. That's all for today. Thank you and have a nice day.